Chapter 3, logarithms. Do you remember in elementary school you had to learn math facts? Did you have like math facts you had to do in elementary, like practice your, all your adding stuff? Or did anybody do flashcards or times tables? Okay, or you had to memorize we used to call them math facts, right? Do you know your math facts? What's 3 squared, right? And you got to shoot it off, okay? What's 4 cubed? And you had to know your math facts. All right, well, we're coming back to it. As good as your math facts are, is how well you're going to, do at logarithms. All right, so logs are going to depend on mental math. Okay, your mental math, you're going to need to know your math facts. All right, so let's start with the basic ones you need to know. You need to know your squares. Okay, your squares, starting with, not 1, but starting with, you're going to need to know, 2 squared, and 3 squared, and 4, and 5, and 6. You should know those up to probably 12 or 13. Okay, so you need to know your math facts for your squares and on down. So clearly, equals 4, equals 9, equals 16, equals 25, equals 36. 169. Right, you should know your cubes. So 2 cubed, 3 cubed, 4 cubed, that was 4, there we go, 5 cubed, that's probably good. And maybe you can skip the rest of them, but I'd like you to know 10 cubed. And so 10 cubed. All right, so 2 cubed is 8, 3 cubed, 27. These should be things you really don't have to think very hard about, that you just know. 10 cubed, anything with a 10, when you cube it, you just group up the number of zeros. So a cube has 3 zeros, so that would be a 1 with 3 zeros. All right, you should know your 4th powers. Up to 5 also. Okay, 2 to the 4th, 3 to the 4th, 4 to the 4th, 5 to the 4th, 10 to the 4th. Okay, so you should know those. 16, 81, 256, 625, and then 10,000. Okay, let me show you how knowing your powers is going to help you know your logarithms. Because logarithms are just based on math facts. All right, logs look like this. The abbreviation for logarithm is log. We put a little b down here. We put an a here. And we put an n there. Each of those positions means something. Okay, b is what we call the base. In these math facts columns, the bases are the rows, okay? Bases go, I'm going to color code mine. Bases go this way. Those are the bases. Base 2, so anything going across. So this would be like the base, this whole row. We call that the base 3 row. All right, A is the value. A is the column. All right, so A are these numbers here. Okay, so I'm color coding mine green. Okay, that's the A value. N is the number of the power that you're in. Okay, that's the power number. And so that's the title of the column you're in. Square, cube, fourth, whatever column you're in, that's the power number. So if you know your math facts table, you'll be able to answer log questions. So let me throw some log questions out to you and see if we can figure out our math facts table and see how that's going to go. Okay, I'm going to give you log base 381. I'm going to give you log base 525. And I'm going to give you log base 10 of 100,000. Okay, so if you know your math facts, this is how we're going to start this out. Log base 3 of 81. You start at the base, which is base of 3. Okay, that's the yellow row. I've circled it in yellow. Okay, so I know I'm base 3. You find the value 81. So that's helping me sit like right here. That's that one. The answer to the logarithm is the title of the column that you're in. What power is that? That's part of that intersection of 3 and 81. And so the answer to that would be what? What column am I in? I'm in column 4, right? And the answer is 4. That's it. Every answer is just like a number. Okay, just a whole number. Log base 5 of 25. Okay, well for that one, you got to think of what base 5 is. So there's my base 5 row. I got to find the value of 25, which is right here. And then I just have to understand what column I'm in for that. And so the answer to log base 5 of 25 is what? 2. Okay, now log base 10 of 100,000. That's not, we didn't write out that math fact, but let's see if we can figure it out. Okay, we're thinking about the base is 10. And this thing's got 5 zeros on it to make it 100,000. So what do you think the answer to that is? 5. That's right. It's 10 to the 5th. You can always check your work by doing this a little math over here on the side. Okay, check your work. If you think the answer is 4, then check 3 to the 4th. Did it turn out to 81? Yep, then your answer is right. Okay, if you think the answer is 2, then check 5 to the 2nd, 5 to the 2, and it is, yep, comes out to be 25. If you think the answer is 5, then check 10 to the 5th, and it comes out to be 100,000, and so your answer is right. So you can always check your work. Check, check, check. That's called the exponential form of something compared to the log form of something. Okay, then we've got a whole new set of math facts, which are the negative squareds. All right, so let's make a new math facts. Shoot, this is what I want. Negative square, negative cube, negative fourth. Okay, these are all negatives. Okay, well, how does that work out? How does 2 to the negative square, 3 to the negative square, 4 to the negative square, 5 to the negative square, 10 to the negative square, how does that work? Okay, these all have the same answers or similar answers as their positive squared ones. They're just all fractions. So if 10 to the positive square is 100, then 10 to the negative square is the fraction 100. All going to work backwards. If 5 to the positive square is 25, then 5 to the negative square is the fraction 1/25. Okay. Negative powers are just fraction answers. And so 1 over 16, 1 over 9, 1 over 4. Negative squares make fraction answers. So the same thing would be true for all the cubes. If you add 2 to the negative 3, 3 to the negative 3, 4 to the negative 3, 5 to the negative 3, 10 to the negative 3, all of their answers are still cubed answers. They're just in the form of a fraction instead. Okay, does anybody want to try going down that column for me? Okay, go for it, Jared. 1/8. Uh-huh. Very good. These are tricky. A lot of times when you're getting tired or you're getting sloppy, I will get answers that are negative answers. And I got to go, no, 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 no. A negative power is not a negative answer. A negative power is a fraction answer, not a negative answer. And so you do the same thing with the fourths Okay, 2 to the negative fourth, 3 to the negative fourth, 4 to the negative fourth. Just practice these so you've got your math facts in your head. And so you can make them all fractions. So it'll be 16 but as a fraction, 81 but as a fraction, 256 but as a fraction, 625 but as a fraction, 10,000 but as a fraction. So that's going to help you do some other example problems once you've got those math facts down. All right, so some problems like that. Okay, what if you've got, okay, the log base, let's do, log base 3 of the fraction 1/9. Or the log base 7 of the fraction 1/49. Or the log of the base of 6 of 1/6. Let's do, if you have an eraser, let's make that a 27 just to keep our answers interesting. Okay. So these fraction answers all mean they came from columns that were negative powers. So the log base of 3, this is how it's read. Log base 3 of 1/27 is a negative cube. Log base 7 of 1/49. Now I didn't make a math fact row for log base of 7, but you know what 7 and 49 is connected, right? What's the power? A square, but because it's a fraction, it should be a negative square. How about this last one? Ooh, -1. Good. Okay. The 1 means the number doesn't change. 6 stays 6. The negative makes it a fraction. Okay. Now we need to learn our first property. Okay, our first property is what is the log base b of the number 1. And that property says the answer to that is always going to be 0. No matter what the base is, the answer to that value is always going to be 0. And so people try and throw those in as like trick questions. Log base 5 of 1. Log base 17 of 1. Log base 1,000,000 of 1. And we'll like throw those in there. The property is, no matter what the base, the answer to that will always be 0. So that's the first property. Okay, second property. All right, what do you do with a large base? All right, if you get stuck and your base is larger than something that you're comfortable with, okay, there's an awesome property that you can use to help make that problem easier for you. Okay, all right, so if you end up with the log base b of a, and that's too hard for you, okay, because the base is too big, you're allowed to switch them and put it in a different order. Did you see what I just did? I switched B and A and A and B. Okay. And you're allowed to figure that out. If that's an easier problem for you, figure that out first. Once you figure out the easier problem, that will give you the answer to the harder one, and the answer will be the reciprocal, 1/n. That's a property. So if you don't like how the order of the answer, the problem is, then try switching. So I'm going to show you a couple of problems where that works out. Okay. So for example, suppose you have the log base 4 of 60, the log base 64 of the number 4. That's tough because the 64 is a really large number, way larger than the 4. And so that's hard to figure out. So try switching it and try putting the 4 and do the 64 that way. Hopefully that's easier for you to figure out. Hopefully, oh, I know my math fact there. I know that the row of 4, and I know the value of 64. What's the answer to that going to be? The answer to this one is going to be 3. Okay, the answer to that one is 3. So then that means the answer to the top one is going to be the reciprocal. That will work anytime you want to switch where you've got something that's too large. Okay, for example, if you got the log of 625 of 5, you're like, oh, okay, that math fact, I don't know. But if you try switching it around, and you put the 5 on the bottom and the 625, hopefully you do know that one. And hopefully you know, oh, that math fact turns out to be 4. Because I learned my math fact of where the 625 was in the column of power 4, which means the answer to the other one is 1/4. Okay, another thing I wanted to show you is that the number 10 isn't always written. Okay, you could have a log that's written like this, where it seems like the base is missing, and that's intentional. All right, they don't put the number 10 if it's the base. Okay, they won't write it there. It'll look like it's blank. It's similar to the way we write our square roots. You know how we have our square roots, but then when we add the 3 and we add the 4 and we add the 5. So have you ever wondered, like, why do we put the 3 there and the 4 there and the 5 there? Why don't we put a 2 here? Right? Why don't we do that? Okay? It's just like, they probably used to back in the day, but it's so common that they just stopped writing it and said, okay, if we don't put it there, everybody assume that it's a square root. All right? And so the same thing is true in a log. If you don't have the log written there, it's a 10. All right, so let's find out the answer to this. Assuming that it's a 10, and you count up how many zeros, what's the answer to this? Count up your zeros. 6. Yeah. All right. Now, every once in a while, they'll throw these in. A decimal log. All right. That is when you are going to need to grab out your calculator. So could you do that for me and grab your calculator out, and let's practice where the log buttons are on your calculator. All right, so that log button on the left-hand side of your calculator next to number 7, just go ahead and push that and log, and then it'll give you a parenthesis, and you put in 2.71, and then you're going to get a decimal answer. So if you were rounding that to 3 decimal places, what would you get? Okay, you get 0.433. So how would you check your work on that? Okay, to check your work, you need to use the number 10, because remember, it's implied. If the number's not written there, it's a 10. And try 10 to the 0.433. Now type that into your calculator. Okay, 10 to the 0.433. Check your work. What do you get? 2.71. All right, so that checks out. There's another logarithm button on your calculator called an ln. It's a special kind of log called a natural logarithm. Okay, ln. Anytime you're asked about ln, you're going to use your calculator also. So do you find the ln button? What number is it nearest on your calculator? It's right below the other one, so it's kind of near the number 4. All right, so go ahead and try ln for 17, and you're going to get a decimal for that too. So rounded to the nearest number, that nearest 3 decimal places, that would be 2.833. So you have a section of your homework for logs that's just typing it into your calculator. So there's not a whole lot of work to show. Your homework over the weekend is probably just going to be a column of numbers, which is easy to cheat on. But if you don't understand these math facts, then it's going to make the entire chapter hard. So don't just cheat on these. Don't look them up, or really think about them and make sure you know these without that you know your math facts solid. It'll make the rest of the chapter a lot easier if you can get these tables that we made. Okay, the one for the squares, the cubes, and the fourths, and the one for the negative squares and cubes and fourths. If you can get those tables in your memory, then it's going to make everything we do with exponentials be that much easier. All right, how do you check your ln? Yeah, the letter E is associated with how you check an ln. So to check, you're going to use the E button to 2.833, and that'll work out to, that should be, E is right above the ln, and that should work out to be pretty close to 17, I mean. And that would be how you check your work for that one.